So today we're going to be talking about systems of equations. There's really four methods when it comes to this type of problem. You can do addition, subtraction, multiplication, otherwise known as elimination, or you can do substitution. So I have my addition problem all set up here. We have a system of equations of 4x plus 5y equals 3 and negative 4x plus 6y equals negative 14. So usually when you have this sort of problem, they're just going to put this little squiggly right here. And that's going to mean that that is your system that you're going to use. So we're going to take these equations here, and I'm going to rewrite them just to have a clear picture of what we're doing. You don't have to. You can just go right in and add them together. But I like to have it a little bit more neat so I can see what I'm doing. Okay, so you can probably already tell we have this 4x here and this negative 4x here. So if we're adding for addition, so we can even do this, we can have a plus sign right here, and just like you would add regular numbers, now we can add these two equations. So make sure you remember all of these are separate terms, right? They all stand alone in this part here, and we can add these together. So if it's on top and on the bottom of itself or each other, then we can add them together. So we're adding 3 and negative 14. So that's going to be negative 11. And we're going to bring down the equal sign. We're adding 5y to 6y, so that's going to give us 11y. Okay, and that's positive, so we're going to add a plus sign here. And then finally we're going to add 4x to negative 4x. So 4x minus 4x gives us 0. So it's really just going to be nothing. You don't even have to write the 0 here. You can even just write 11y equals negative 11. Okay, so now we're going to simplify. So we've added the terms together. So add terms. Okay, and now we're going to simplify this equation we got here. So now notice that we have only one variable. The goal was to eliminate this x so that we can just have one variable that we can solve for with one equation. So however many variables you have, if you have that many equations, you can solve for those variables. So we have one variable, one equation. Now we're going to go down here and rewrite it so it looks nicer. Equals negative 11. Okay, and I'm just going to go in and divide by 11 on both sides. What you do to one side, you must do to the other. Okay, and then we're going to get y equals negative 1. Okay, so we have our first variable. Now we're going to go back in and plug it in to one of these equations, whichever one is easier usually. So I'm going to use this first one right here. So let's see, 4x plus 5y, so y is negative 1. I'm going to put that negative 1 there, equals 3. Okay. Alright. We're going to multiply these out together. We'll say negative 5. You can also do minus 5. It means the same thing. Okay. Alright, we can't combine these because this has a variable attached to it. So we're going to move this over to the other side here. Add 5 to both sides. And then we get 4x is equal to 8. And then we're just going to divide by 4 to isolate that x. And we're going to get x equals 2. So we have our two variables that we wanted to find from the beginning. And now the most important part, if you have time, is to check your work. So we're going to check here. We're going to plug these back in to one of the equations and see if it works. So I'm going to use the first one again just because it's easier. So we're going to do 4 times 2 plus 5 times negative 1. So these are just the variables. I just put them right into this equation up here. Is equal to 3. So it's going to be 8 plus negative 5, or 8 minus 5, equals 3. And let's see, so 8 minus 5 is indeed 3. So I'm going to put a little check mark. It does check out. Okay, so that's addition. So that's the first way that you can deal with this type of problem. And now we're going to move on to subtraction. Okay. Alright, so for subtraction, the deal is pretty much the same, but we're going to be subtracting, right? So for subtraction, we're going to need something that we can turn negative in a way. So I'll show you right here. So if we have x plus 2y equals 4 and 13x plus 2y equals 28, then we have a system. So this is really similar to the one before. We have a 2y and a 2y, but both of these 2y's are positive. So if we end up adding these together, then we're just going to get 4y and they're not going to cancel out. So what we need to do is we need to turn one of these equations negative. So I would say, we can do top or bottom. Well, let's do the bottom just for the sake of the visual. So I'm going to rewrite it down here. Plus 2y equals 4. You can even change the order too if you want. And then we're going to do the bottom one. So 13x plus 2y equals 28. So nothing has changed yet. Okay. And we are going to turn this equation negative. So we're going to just put parentheses here, and you can think about it, we're just going to multiply -1 with each of these terms. So if you remember distribution, we're going to distribute that 1 to each of these. So it's going to be -1 times 13x, -1 times 2y, and -1 times 28. So that's how we're going to change this. Okay. Alright, so now we bring down the same equation from the top. And now we have -13x minus 2y equals -28. Technically, you can even do this, instead of doing this -1, you can just do minus, minus, minus. That also works. For me, it's just easier to do it this way. So we're going to go ahead and subtract these. So x minus 13x gives us -12x. 2y minus 2y, it's going to give us 0 because it's positive and negative, so it cancels out. Okay, and then we have 4 minus 28, that's going to give us -24. Okay, so we have one variable, and that variable is going to be the one that we're going to find now. So we're going to simplify this. Let's see, so -12x equals -24. So pretty straightforward. 12 is half of 24, so we can divide by -12 on both sides. X equals 2. Okay, so we have one term. Now we're going to go ahead and plug this variable back in. So I'm going to take the top equation, and instead of x, I'm going to put 2 plus 2y equals 4. I'm going to subtract 2 on both sides to isolate the y. Okay, and that's going to be 2y equals 2. Divide by 2 to isolate the y. And finally, we're going to get y equals 1. So we have our two variables, and now we have to check our work. So I'm going to take that top equation again, and I'm going to plug the variables in. So x is 2, plus 2 times y, which is 1. 2 plus 2, 2 times 1 is 2, is equal to 4, and so our check checks out. Okay, so that was subtraction. Let's move on to multiplication and elimination. Okay, here we go. So for multiplication, it's also really just what it sounds like. You're multiplying across the entire equation. So for this one, we're going to use the system. Let me do this first. Multiplication. Okay, we're going to use the system 9x plus 6y equals 21 and 5x minus 3y equals 37. Okay, so that's our system. Alright, so I'm going to bring it down here. Fantastic. Okay, so for multiplication, none of these really match up. We can't really eliminate any variables. Well, this one's not important. We can't really eliminate any of the x's or y's. So what we're going to have to do is we're going to have to multiply one of these equations to make it so that we can add these together and have them cancel out. So I'm going to choose to multiply this equation by 2. So same deal as before, we're going to distribute. So I'm going to bring this down. 9x plus 6y equals 21, that doesn't change. And now we're going to do 2 times 5x, which is 10x, 2 times negative 3y, which is negative 6y, and finally 2 times 37, it's going to be 74. Okay. Alright, and so finally we can go ahead and add these together. So now we're going to use addition. And I'm going to bring this down right off the bat. We know that 6y cancels out, so it's going to be 0. And then 9x plus 10x is 19x. And then we have 74 plus 21, 7, 8, 9, 4, 5, 95. Okay, so we're going to go ahead and simplify here. So we have 19x equals 95. So we're going to divide by 19 on both sides. And let's see here. Okay, so x is going to equal 5. It's kind of an unusual number, but we have our variable. Alright, so now we're going to plug it into the equation again, just like with the last two. So 9x plus 6y equals 21, so that's the same equation from the top. We're going to plug in x, so 9 times 5 plus 6y equals 21. And now we're just going to simplify everything out. So 9 times 5 is 45, plus 6y equals 21. Move the 45 over here to isolate the y. And we have 6y equals 21 minus 45, so it's going to be negative 24. Okay, awesome. So now we're going to, again, isolate the y, so we're going to divide by 6 on both sides. And we're going to get y equals 6 times y is 24, and it's going to be negative. It's going to be 6 times 4 is 24, so negative 4. And that is our second variable. And of course, now we are going to check them. So instead of the first equation, I'm going to go ahead and use the second equation. So 5x minus 3y equals 37. And we're going to plug the variables in. So 5 times 5 minus 3 times negative 4 is equal to 37. So 25 plus, because we have a negative here, 12 is equal to 37. See, 2, 3, 5, 6, 7. All right, it is in agreement. So this is, in fact, correct. Awesome. So that was our third way to do systems of equations. And last but not least, we're going to do the last method, which is probably the hardest, but also my favorite. So we're going to do some substitution. Okay, cool. So our system, and we know that y is equal to 3x minus 3. So we can take this y, and we're just going to plug this number here into this y. So notice that we're not taking this equation and finding y and plugging it back into itself. That would just, I don't know what that would give you. It wouldn't give you the right answer. We're using the other equation to find what the other equation says y is, and we can use that here and substitute for this one. Okay, so we're just going to go ahead and plug it in. So 2x plus 5y, where y is 3x minus 3, is equal to 19. And this is also where you really have to have your distribution skills sort of developed. Okay, so we're just going to simplify. Let's see, so it's going to be 2x plus 5 times 3x, which is positive 15x, and 5 times negative 3, which is negative 15, or minus 15. And all of that equals 19 still. So now we're going to combine the like terms. So we have 2x and 15x, and then we have negative 15 and 19. So these two are easy, so we're just going to add these two together. So we're going to get 17x, and the negative 15 and the 19 are a little bit more tricky. So we're going to add 15 to both sides. And then we're going to get 17x equals 19 plus 15. So that's going to be 34. Okay. So we're going to divide by 17. 17 times 2 is going to be 34. So x equals 2. Okay, we have our first variable. So now we're going to get y, just like the last couple times. So we're going to say y equals 3x minus 3. Same equation as up there. Y equals 3 times 2 minus 3. Substitute the x with what we just found. And we're just going to simplify. Y equals 6 minus 3. So y is equal to 3. Awesome. So we have our two variables. And now we're going to check to see if it's the right answer. So I'm going to take that same equation because it's so nice. Just like that. And we're going to plug it in. So y is equal to 3. And x is equal to 2. And now we're just going to simplify. So 3 equals 3 times 2 is 6 minus 3. And 3 does in fact equal 6 minus 3. So we're going to go ahead and say that our answer is correct. Okay. So I hope that was a big help for anyone out there who's struggling with this sort of equation. You can use these in a variety of ways. You can actually mix these together, and that's usually what teachers will have you do. But first you have to learn the basics. So I hope I was a good help. And yeah, enjoy math. Goodbye.